We've all seen that famous illustration, a knuckle-dragging ape standing up, turning into a modern human. But that straightforward march of progress is completely wrong. Instead of a single straight line, human evolution looks a lot more like a tangled, bushy tree. For millions of years, the planet was crowded with multiple different human species, living at the exact same time, trying out different survival strategies. Some lineages pushed forward, while plenty of others failed and ended up as dead ends. The earliest branches of this tree belonged to species like Sahelanthropus and Ardipithecus. They had brain sizes similar to modern chimpanzees and kept grasping toes for climbing trees. But they shared one crucial unifying trait: the ability to walk upright on two legs. Physical evidence for this exists in fossils like this one, an Australopithecus known as Lucy. Examining her lower limbs and pelvis gives researchers clear proof her species regularly walked upright across open landscapes. Walking on two legs freed up the hands for entirely new tasks. That biological shift kicked off a chaotic, multi-million-year experiment to see which traits would actually keep a species alive. One highly successful strategy was to stop waiting on biology entirely. Around 2.4 million years ago, a species called Homo habilis began developing external solutions to their environmental problems. Look at the chipped edge of this stone tool. Homo habilis struck rocks to create flakes, quickly cutting raw meat and cracking bones for calorie-rich marrow. By shaping these stones, hominids bypassed millions of years of biological waiting, outsourcing their physical evolution entirely to technology. Homo erectus took this versatile strategy even further. They learned to control fire, which offered immediate warmth during cold nights, scared off apex predators, and allowed them to cook their food. Cooked food is much easier to chew and digest, freeing up biological energy that likely fueled larger brain growth over time. Armed with fire and refined stone tools, Homo erectus managed to migrate out of Africa and thrive across widely different environments in Asia and Europe. A growing brain combined with external tools created a highly versatile generalist. Instead of needing their bodies to adapt to a new climate, they could simply mold the environment to fit their needs. But not every branch on the family tree went the generalist route. Several species adopted the exact opposite strategy, radically altering their physical biology to dominate very specific, extreme ecological niches. Take Paranthropus. Looking closely at this skull, you can see massive jaws and thick facial bone structures anchoring heavy chewing muscles. They evolved this specialized hardware specifically to grind down tough, fibrous roots and rough vegetation day after day. Up in Ice Age Europe, Neanderthals specialized for the freezing cold. Their bodies grew shorter, thicker, and heavily muscled to retain heat, while large noses helped warm sub-zero air before it ever reached their lungs. Over in modern Indonesia, Homo floresiensis found themselves trapped on a remote, resource-starved island. To survive unlimited calories, they underwent a process called island dwarfism, shrinking down to an average of 3 feet tall. And high in the mountains of Asia, an elusive group known as the Denisovans developed unique genetic traits. These adaptations allowed them to process thin, oxygen-deprived air and endure brutally cold altitudes that would exhaust most other species. These biological adaptations made them undeniable masters of their specific niches. But that mastery came with a fatal flaw. When the climate shifted rapidly and their environments vanished, their bodies lacked the flexibility to adapt fast enough to survive. For a long time, scientists assumed hominid evolution followed a strict rule. Complex, intelligent social behavior could only emerge in species that had already grown large, modern-sized brains. That rule shattered deep inside the hazardous, nearly inaccessible cave systems of South Africa, where researchers pulled out an unexpected set of fossils belonging to a species called Homo naledi. Homo naledi presents a major paradox. Their brains were a fraction of the size of ours, yet the massive concentration of their remains, tucked away in these impossibly tight passages, suggests they were deliberately bringing their dead into the cave, a sign of deep social complexity and care. Their existence proves that behavioral complexity isn't a simple math equation based on brain volume. The messy tree of human evolution clearly has a few branches that defy our expectations. About 40,000 years ago, early modern humans, often called Cro-Magnons, entered prehistoric Europe. They arrived as the ultimate generalists, armed with highly coordinated hunting tactics, fitted clothing made from animal hides, and advanced tools crafted from bone and antler. They also brought an unprecedented level of cultural cognition. Look at the careful observation painted on these cave walls. These vivid animal figures show a species actively studying and communicating the natural world. Between the rapid climatic shifts of the Ice Age and the intense resource competition from these highly innovative modern humans, the specialized branches of the human family tree simply ran out of room to survive. But those ancient relatives didn't entirely vanish. Modern genetic testing shows that as early humans spread across the globe, they met and interbred with both Neanderthals and Denisovans. We aren't the pristine pinnacle of a straight line of progress. We are the surviving patchwork product of a 7 million year biological experiment, and we still carry the genetics of our extinct cousins in our DNA today.